second period didn't work very good. All right, so a zoo has just opened a new gorilla exhibit that has a total of 5,400 square feet. Zoo regulations require that each gorilla have at least 8,500 square feet of space. How many gorillas can be housed in this exhibit? What do you guys think? Okay, 6. What'd you do, Peyton? 54,000 divided by 80. 8,500. That did not give you exactly 6, right? What'd you get? 6.352. However, using your common sense, you know that you cannot have 0.352 of a gorilla, right? So 6 gorillas. So this one gave you that density you needed for each gorilla, and you kind of had to work to find how many were possible here, right? Okay, the next one, there is an island located off the coast of South America that is approximately 4,500 square miles and contains 608,000 inhabitants. According to the previous year's hospital records, 11,275 children were born last year, but 9,850 inhabitants died. The local government on the island believes that they can support a population that is as dense as 135 people per square mile. Given last year's medical records, can the government support the new population? Okay, so to do this problem, we know that we can only support 135 people per square mile. So we need to find the current population density, right? So that's our number of people divided by our area, people divided by square miles. So we got to find our current population for this. So we started out with 608,000 people, but then that population changed. So for this, Rhett, what should we do to that 608,000 to find the current population? Okay, so whenever we have children born, what does that do to our population? Adds, right? So we need to add 11,275. When we have inhabitants that die, what does that do to the population? Subtract. So 9,850. So if we do that, you're going to get like 609 something. Okay. 609,425 people. So that is your current population for this particular island. And that is people. And we need to know the number of people per square mile. That word per, it means to divide. For this, if we want to know the people per square mile, we need to take our number of people and divide it by our number of square miles. So in this case, we have 45,000 square miles. So we will divide this by 45,000 square miles. And that will give us 0.9425 divided by 6. We're going to get 135.428 people per square mile. So, can the government support this new population? If you round down, yes. But if that's a hard line, no, they cannot, because you have a greater than 135 for that. So this can be really important, because whenever you're talking about like this particular island right here, you have limited resources for any area, right? So you could be talking about things like food or housing or things like how much waste your like sewer systems can handle, or your capacity for like water for the whole island, those sort of things, power for the whole island, because every additional person is going to use up a little bit more of all of those things, right? So if you are a government official and you were recognizing, oh, this year's population, we're starting to go above 135 people per square mile, what would you have to do? Now, there's one option of reducing the population. In most cases, I can't think of too many ethical ways to reduce the population, right? Because you're either going to have to kill people off or ship people out, and either way, there's a lot of questionable things going to happen for that. Now, you could influence future populations, so like you could make policy changes that might possibly affect future generations. That is difficult to do. For example, China had the one-child policy, right? It was effective, and now their population is not growing anymore. Their population is declining. And now China has increased to 2 kids and then 3 kids, and guess what is happening? Nobody's having kids still. It became like ingrained in the culture. So now most people in China don't want to have lots of children, and they are not having lots of children, and their population is in decline, which can be good for things like the environment because you have fewer people using resources, but it can be bad for things like the economy because you have fewer and fewer people that are working age, and you have a lot of old people with not a lot of young people still working to take care of them. You might have a lot of people who are getting old who don't have children or only have one child, and it's very difficult for that one child to take care of their parents, or if they have no children at all, whenever they get old, they might. So anyway, it's difficult to influence population change. You can do things to influence population change. My grandpa had 10 brothers and sisters. You hardly ever see anybody that has 10 brothers and sisters anymore. So, in that time, it was big agriculture. You had lots of kids to work on your farm. That certainly was the case. If you look back in your families probably far enough, you might find that there were lots and lots of siblings there. That's not really the case anymore because of, changes in farming. So it's a lot less common to see something like that, although still occasionally there'll be big families. But so getting rid of people is questionable here. That's probably not going to be a viable option for this unless you're an evil dictator who is going to wipe out large portions of your population. So what else could be done to fix the situation? Because in this particular situation, you're not far over the mark, but you're over the mark where you don't have enough resources for all of your people. Okay, that is an option, right? And it's certainly an option that governments have chosen in the past. You could, now in this case, you're looking at an island, so there would have to be like a lot of travel back and forth, but that's an option that several governments have chosen before, right? It doesn't always work out great, but you could try. Wars also decrease population as well, but that you could try that. Preferably, it would be nice if you could look into increasing your resources, because if it is food, you could look at maybe being able to import more food or ways to grow more food on the island. Maybe there's some land that's not being used that you could grow food on. If it's something like housing, you could look at ways to build new housing for these people, ways to make that affordable for people. There could be a lot of different things. Maybe it is the sewer systems that can't handle this anymore, or the power grid. So you would maybe look at trying to improve something like that so that you could sustain more people for that. So I think that's kind of like an interesting way to look at, or interesting thing to think about.
You know Elkin's population?
It's around 4,000. What is it?
4,060, because I was in 2021.
4,060. I think that's got to be just the town of Elkin,
Yeah,
like
that's just
city
the town.
limits.
City limits.
I don't think that counts like us that live in the
Surrounding area.
the greater State Road area. I'm Elkin City Schools District, but not an Elkin address. Surrey County's like what, 70,000 people?
71.
Yeah.
Most counties 65, but these are in 2021. So
Yeah.
It's not really.
Yeah. Usually, though, you don't see huge changes from year to year. You'll see some. So.
Mount Airy. Mount Airy's big, aren't they?
What's Mount Airy got? Mount Airy's going to be a little bit like Elkin, though. Like
10,000.
a lot of Mount Airy is not in city limits. And my parents don't live in city
That's still
limits.
Surrey County.
Yeah. Well, Mount Airy City Schools is not a Surrey County school system, but Mount Airy is in Surrey
Kind
County.
of like Elkin City.
There are only like 115 or 117 school systems in the state. Most counties just have one school system. There are like 15 city school systems, and Surrey County has 2 of them. So interesting situation there. There could be lots of reasons for that.
1999 it went from 7,000 to 11,000.
And Mount Airy.
7,874 to 10,960.
Oh, yeah.
In a year.
That does kind of make sense. They've added a lot of stuff in Mount Airy.
That's right there. For general wise.
Yeah, it is. All right. So let's look at density from more of a from like a scientific sort of standpoint. Density can be really important. Before we talk about density, we need to talk a little bit about this word right here, mass. Okay, so your mass is going to be measured in, typically whenever we talk about mass, we talk about kilograms or grams, most likely. So mass is typically going to be kilograms or grams, or it could be another variation. It could be like milligrams. In medicine, a lot of times we'll use milligrams. So you might take 400 milligrams of ibuprofen or something. So you'll see that a lot. But grams, some sort of grams are typically what we use. In the good old US of A, we don't use kilograms very often, right? What do we use instead? Here. If I ask you how much you weigh, what are you going to tell me? You're going to use pounds, right? So now in science, they rarely ever use pounds, but they could if they wanted. They are generally going to use the metric system. However, technically pounds is a weight. Okay? Your weight can change. Well, your mass can also change. Like if we're talking about a person, but let's say this calculator. The weight of this calculator can change. The mass of this calculator cannot change unless we destroy it or break it apart or change, do something like that to it, burn it, something like that. But if I have this calculator, its mass does not change. My mass can change because I can get bigger or smaller, depending on, weight gain or loss. But the calculator's mass never changes. Its weight could change. How could I change the weight of the calculator without changing the calculator? No, that would change the mass, but that would also change the weight as well. So, like, if I'm saying this is like 1 unit right here, it's a little bit of a trick question.
Why? When the batteries
It's possible there could be some chemical changes there that might like have something happen. That's possible, but it would be changing, like that would change the mass also if that happened. So something like for the mass to stay the same but the weight to change, what could I do to this calculator? I'd have to change gravity. So if I took this calculator to the moon, it would not weigh the same. Its mass would be the same. So, like if the moon, for example, is about 1/6 of the gravity of the Earth. So if somebody weighs 100 pounds on the Earth, if you take them to the moon, then they only weigh like 15 pounds, something around 15 pounds. So, however, their mass would still be the same. Now, the way on Earth that we measure mass is usually by using weight. Because you might wake up in the morning and step on the scales, right? And if you step on the scales here and it tells you that you weigh 100 pounds, right? If you take that same scale, and whenever Elon Musk gets all of his stuff ready, you pay billions of dollars and go fly to the moon for vacation sometime. That's his plan. And you're going to take your scale with you. You set that scale down on the moon and you step on the scale, you're only going to weigh 14 pounds. It is not because you lost weight on the way to the moon. It is because the moon has less gravity and weight is dependent upon gravity. That scale is measuring the force that you are pushing down on that scale. On the moon, you are not going to push down as much because the gravity is not pushing you down as much. But your mass should be relatively the same as it was whenever you left Earth. You're not going to lose a lot of weight. Maybe, I don't know, maybe a pound or two, but you're not going to lose a lot. So we use weight to measure mass typically because on Earth our gravity is constant. So our scales are going to measure that. If we find our weight, we can translate that to our grams. But mass is not changing there. So kilograms, grams, milligrams, we use those for mass. Volume, let's talk about what types of units you will have for volume because that is important as well. For volume, you can use cubic units. So it could be something like cubic meters or cubic centimeters or, Adriellis. Coach Carter needs you to go up there to talk to him. So you can take your stuff with you. He said it'd take about 15 minutes. You already have the worksheet that'll be the homework. I'll post this video too if you need this last 15 minutes. And then there's another way we can measure volume. Sometimes, particularly for liquids, a lot of times we don't use cubic meters, cubic centimeters. What do we use for liquids a lot? Milliliters, liters, fluid ounces if you're in the U.S., but in science we don't use that very much, right? But you could see gallons, cups, liters, fluid ounces, those sort of American standard units. Quarts is American, yeah. Yeah, but that's still American. If you were mixing paint ratios in Argentina, you would be using liters. So just here in the good old U.S. of A., we like our gallons. So you might see some of those, but typically if it's science related, you're going to see metric system. So number 7, the density of water at 30 degrees because your heat can change your density. So like when you heat something up, it'll increase or decrease your density. For example, did anybody else's tire pressure alarm come on their car this morning? And I had a few people in second period that it happened to. But if your tires have the alarm on it that tells you your tire pressure is low, like mine were low this morning, and it wasn't because they were leaking, it was because it was so cold. And it was so cold where my tires were not quite as inflated because all the air had it's shrinking in because it's colder. My tires need just a little bit of air for the winter, but they're not like leaking. Actually, I might have one that is lower than the others. It might have a leak. I've had some trouble with that one, but most of them are just because of the weather. So that affects here. We have the density is 995.65 kilograms per cubic meter. This figure below has a mass of 540,000 kilograms. I want to know if it will float in 30 degrees Celsius water. That should say in right there. So I need to know mass and volume. They gave me mass, right? Mass is 540,000 kilograms. All right. I need to know volume, but I don't have volume. So I am going to have to find the volume of the cylinder. So volume of a cylinder is pi times the radius squared times the height. So I'm going to do pi times 5 squared times 8. And so if I type that into my calculator, pi times 25 times 8 is going to give me 628.319 cubic meters. So I need to divide this by 628.319 cubic meters. So if I do that, 540,000 divided by that number that I just got is going to give me a density of 859.437. Make sure you put units with this because it matters, kilograms per meters cubed. Because when I'm looking at this right here and comparing it to this right here, if my units right there aren't the same, I can't really compare them to each other, but they are in this case. So, will this float? What's going to happen if I have a lower density? It will float. If I have a higher density, if the density is higher, it will sink in this case. So, density of water is 995. Density of this object is 859. So since this has a lower density than water, it's going to float.
The water bottle has
500 milliliters. We could weigh it, although I don't have a scale, and we could find some density there. Although yours is not full of water, so its density would be different. Yeah. So this would float. If you had something with greater than 995, it would sink. I bet that sometimes I see in stores like these like tubes. I haven't even thought about this till now. These tubes that have like these different little things floating in water. And it's like a temperature scale, and I bet this is how it works. Like it's got just the right density, where if it's a certain temperature, it'll like go up or down, like sink or float. I think maybe, I don't know.
different little bubbles in it, and it goes up and down.
Yeah, I think that's how this works right here. Like as the temperature goes up, the density of that will increase or decrease. So
They each
it'll,
have different weights on them.
yeah.
Yeah.
I need to know more about that. All right, so let's do a couple more density problems, and then we got to go. I'm going to skip 8 and go to 9. So 9, if you have 28.5 grams of metal and it's added to a graduated cylinder that contains 45.5 milliliters of water, and the water level rises to 49.1 milliliters. Calculate the density of the metal. Sometimes you have to do this if you have something that is an odd shape. So if I have like a cylinder of metal, I can just measure it and figure out what the volume is there. But if I've just got like, something that is odd shaped, like the lid of this pen, it's kind of a cylinder, but not really because of this thing. Or I could take that, if I have something like that, then I can't just measure and calculate the volume. So what you can do is you can fill up, a cylinder or whatever with water, see how much is in there, drop in your object, and however much it goes up, that's the volume of your object that you added to the water. So in this case, to find my volume of this particular piece of metal, I would do 49.1 milliliters minus 45.5 milliliters, and I think, what's that give you? 49.1 minus 45.5 is going to give us 3.6 milliliters. So the amount that it changes there is our volume, and then for our density, in science they use this P for density, I don't know why, is our mass over our volume. So that is going to be the mass is in grams, right? It's important to know those units so you know which one is mass and which one is volume. So 28.5 grams divided by 3.9 milliliters. So if we divide those, 28.5 divided by 3.9, we are going to get 7.30. I'm going to round that to 8, 7.308 grams per milliliter. Yes, it is. I don't know why I changed that to a 9.
Like the water towers?
Hold on. What about the water towers?
Like, they're like X amount of water in them, I guess?
Yeah, water towers work using gravity. They're always going to be at a high point in the town, like you're never going to see a water tower down in a... So you'll have a certain amount, and then that pressure from the water just pushes it through the lines. So that's why, like, if you're on city water, when the power goes out, you still have water. But if you're on a well, you don't have any water unless you got... All right, we're going to do one more. I know we're about to go. That should have actually been 7.91. 6 repeating. I did 6.9, 3.9 for some reason. All right, this last one here, we're going to do, we didn't get to do an extra box problem, but we'll do one tomorrow. Try your best on those box problems. At least try to set it up for that. So here, the length of the base of a rectangular prism is given as x plus 4. The width is x plus 2. Height of the rectangular prism is 3 more than 2 times the length. Build a function to model the volume of the rectangular prism. So a rectangular prism is just a box. Like this. Well, it's a bad box, but you guys get the idea. The length is x plus 4. The width is x plus 2. And then they give us the height. Height of the rectangular prism is 3 more than. What does that tell me to do? Three more than.
Times 3.
Not times
Or
3. Plus 3. 2 times, so that's 2 times something. The length, what was the length?
2, 4.
Not just 4. It tells us the length of the base is x plus 4. This was our length, right? So I got to put that x plus 4 in parentheses there. Now, to make our life a little bit easier, let's distribute that. So we'll get 2x plus 8 plus 3. And then I can put 8 plus 3 together, so I'll get 2x plus 11. So this side right here is 2x plus 11. So if I want volume here, it's asking me to write an equation for my volume, right? How do I find volume of a rectangular prism? Length times width times height. X plus 4. Hold on just a second, Miles. X plus 2. 2x plus 11. Multiply those 3 things together. This is what it's asking for. It's not asking for an amount. It's asking for an equation. So if you knew what x was, like if x is 5, you could plug it in. If it changed to 7, you could plug it in and find the volume. Okay? All right, so the worksheet that you guys have for homework tonight, most of it is density stuff. I think there's one like this. There's a couple problems that are those box problems where you're cutting the corners out. So you can look at that one that we did yesterday for that. So do your best on that. Try something on everything. We will spend some time looking at it tomorrow.